So here in problem number 1, it talks about a ball attached to a string is whirled around in a horizontal circle, radius r. If the radius of the circle is changed to 4r, the mass is changed to 4m, and the same centripetal force is applied by the string. What is the new speed of the ball? Well, this is talking about circular motion, so I know I can have F net centripetal equals MAC. It says it's attached by a string, so I know then this is FT equals, mass is good, but I believe I am looking for the speed, so I substitute AC for V squared over R. Let me rewrite that here. Ft equals mv squared over r. So now I can look at what changes happen. If the radius of the circle is changed to 4r, so this gets a 4, so then this side gets a 4. Excuse me, that was incorrect because I'm not looking for the force. The mass changes to 4, and it says the Ft stays the same or stays constant. So this can't change. Okay? So right now I look at this and I have to see if anything changes over here. Okay, well these would just cancel out. So then I have the same Ft, so V is the same. So that gives me E. In this problem we see we got a 4 kilogram mass attached to the end of a 2 meter long rope. It's in a vertical circle. I think some of you missed that. It's in a vertical circle that's going up. What is the tension? So this is a forces problem, so it's at the top. Tension's going down, and gravity is also going down. This one asks for the tension, so I know I've drawn my free body diagram. Then my F net statement equals MAC. So we're looking for the tension. Well, we know to the center of the circle is positive, so tension plus mg equals MAC. Can't cancel out masses because there's no mass in the tension force. Right? So I'm going to have to solve for T here anyways. So I could solve for T, and T equals MAC, but then I would subtract mg to both sides, so this is minus mg. So now I believe I can plug numbers in. So I know the mass. Whoops, I forgot. Let's ask for a velocity, so I got to keep going. Tension equals m times v squared over r minus mg. Now, from here I can plug the numbers in. This is 4 kilograms. The velocity is 5 squared divided by the radius, which is 2, minus mg, which is 40, mass times 10, and by doing this math you will get E 10.8. The last one we'll look at on this page here, let me pause it for a second. Alright, now I'm back. This one says an astronaut in an orbiting spacecraft attaches a mass to a string and whirls it around in uniform circular motion. The radius of the circle is r, the speed of mass m is v, and the tension of the string would be F. Right, now it talks about if the mass and radius were changed. Well, this is a forces problem. Right? Now it talks about here the orbiting spacecraft. Well, in orbiting spacecraft, everything will fall the same, so it will seem like gravity is not there. So then in that case, the only force I have to keep it into a circle is the force of tension. Okay? So my F net statement, F net here equals MAC. So tension is to the center times the mass. Then it asks about velocity, so this has to be V squared over R. Let's see, the radius, right, that should be this line right here. The radius is R, the speed is M, or excuse me, the speed is V, and the tension is this. Oh, here's what I was trying to get. So in this one, if the mass, radius, and speed were all doubled, what would happen to the tension? So here, let's see, mass is doubled, velocity is doubled. Anytime you have it with a v, it has a v squared, so I gotta do this, and r. Okay? So I got 2 and 2, those cancel, so the tension has a 2 squared, which is 4. So this should be 4F.